assignment that is practical and classification. This is for artificial intelligence and machine learning intermediate level for the KITI project. So in this assignment, you are required to train a machine learning model to help in classification of loans as either approved or rejected, and you're provided with the data set that you're going to use for that. You are also required to submit an attachment of the Jupyter Notebook file and a video link that explains the work that you've done. So I'll take you to my Jupyter Notebook file. So this is my notebook file where I have done the assignment. The first step is importing the libraries. So I have imported all the necessary libraries that I need to undertake the assignment. So I have NumPy. This helps in manipulating data in terms of arrays and also performing some arithmetic operations on the data. We have pandas for manipulating data frames or data in tabular form. We have the matplotlib.pyplot, which is used for creating or for plotting our data in terms of graphs, pie charts, bar graphs, or scatter plots. We also have the Seaborn. Seaborn is used for improving on the plots that you make using the matplots. So we move to sklearn, which is a machine learning model in Python. So from sklearn, you are going to import a number of properties or a number of items. So we start by importing from the model selection. So here we import train, test, split. This helps us to split our data set into training and testing data sets. Then we have preprocessing that allows us to perform some preprocesses such as standard scaling and also encoding. We have the compose that allows us to transform or to perform some column transformation. We have the learning model itself. In this case, we are going to use a logistic regression. And then we have sklearn pipeline that we're going to import the pipeline. This only helps us to organize the flow of activities when you're doing the preprocessing. Finally, we are going to import the various reports, such as from the metrics that are going to output the accuracy score, confusion matrix, classification report, and ROC AUC score. And then we're finally going to import the ROC curve. This helps us to plot our results. Now we move to the next step, which is loading our data set. So we are going to load our data set using the pandas. So we use the .read CSV file, which is a function under the pandas library for reading data, the CSV files. Then we store our data on a variable that we're calling the df, that is for data frame. Now to verify if our data has been loaded, we will use the head function. So the head function displays the first 5 rows of our data set. So this is successful, meaning our data has successfully been loaded. Now we move to the next step. Here we are going to do some few data analysis. So in this analysis, we want to check how many loans have been approved and how many have been rejected. So from the data frame, we are going to check on the loan status column and count by values. And then we use the Seaborn to plot our loan status in a bar graph form with the title loan status distribution. Further, we are going to check from our columns which ones are categorical and which ones are numeric. So we use the select data types or select D types. So for for categorical data types, the type is object, and for numerical data types, we can either have integers or floating points. Finally, here we just print which of those are categorical and which ones are numerical. So this is the output down here. So the output here states our loan status distribution is as follows. The ones, which are the approved, are 214. The zeros, which are the rejected, are 186. This has been plotted on a bar graph, and down here we have our analysis of the categorical and the numerical features. Finally, because our learning model, that is the linear regression, only works with numerical data types, so we have to convert our categorical data types into numerical. So if you check our data here, we have employment type, loan purpose, credit history, and guarantors, which are categorical. And for guarantors, the values are yes or no, meaning there are only two possible values. So for that case, we can easily convert it to numerical using the get dummies. So the get dummies there will help us to convert the guarantors from the categorical data type to numerical data types. Finally, we move to we can check that. After doing that, we can use the head again to check. So when you check, if you look at the guarantors column, the guarantors column, you find that now it has changed from yes, no to 1 and zeros. So we have other new categorical data types, that is the employment type, loan purpose, and credit history. Unfortunately, these ones we cannot convert them to numeric using the get dummies because they are a bit more complex. That is, they have more than two possible values. So we have here for employment, we have self-employed, informal, unemployed, and formal. And for loan purpose, we have farming, housing, business expansion, school fees, and medical. And for credit history, we have poor, good, and fair. So all this shows us that we have, they cannot be converted to numerical using the get dummies. So before I forget, we need to do away with our null values. So we use the fill null. So we fill the null values with 0, so that anywhere that is a null, we fill it with a 0. So if we check again using the head, we will find that places that we had a null, for example, in number of membership years, we had null. So if we check here, they are now 0, 0, 0. Now the next thing is that we want to perform some pre-processing. Here we want to scale some numerical features, and we want to encode some categorical features. So I'm going to create a variable here called call to scale. So this one means columns to scale. So the columns to scale, I want to scale the age, the monthly income, loan amount, repayment period, repayment defaults, and membership years. So the scaling here just helps us so that we can have manageable range, especially for data that the ranges are big. If you can look at maybe this column is loan amount, so you see the ranges are too big. So when you use them as they are, the data with the big ranges will dominate our model. So to avoid that, we scale them down so that we ensure that the standard deviation is 1, or the mean is 0. So we'll use the scaling, and now we have the encoding. This one is now converting the categorical data types to numerical, because these ones we saw that they had more than two possible values, so we could not convert them using the get dummies. So we'll encode them. So we'll perform the pre-processing using the column transformer that allows us to convert those various columns. So what are we going to do? The transformers here is, we are going first of all to change the categorical features to numerical features. We call them numbers. And then for the categorical, we are going to scale the numerical features to reduce the range. And then we have the categoricals that we are converting from categorical to numeric by encoding them. So we call the standard scalar, and then we pass in our list of columns to scale, which is what we're passing here, and we call the one hot encoder, and then pass the list of columns that we want to columns that we want to encode. Once we are done, we can do the head. So when we do the head again, we can now see this numerical data, the columns, the age, the monthly income, the loan amounts, and the repayment defaults and membership years. They have been scaled, so they are no more than 1. And now we move ahead to start plotting our model. So for the x-axis, we are going to have all the other columns except the loan status, and for the y-axis, we are only going to have the loan status. Then we move to the next step. We are going to split our data set into training and testing data sets. So this is what we are going to do here. So we split our data into training and testing data sets. So we are going to use the ratio of for test, we are going to use the 20%, meaning the 80% is used for training. So the training here, we now want to train our model. So we want to pass the data that we have set for training. We want to pass it to our model. So before we do that, we have to perform some pre-processing. So in pre-processing, we have what is called preprocessors, the one that we had defined up there, that is here. So we say that there's some preprocessing that needs to be done, and then after we done the preprocessing, which is scaling and encoding, we can now pass our data to the model so that the model can be trained on the data. So the output is here. So it starts with the pipe. The pipe, as we said, is just it shows the series of steps that are followed when performing the pre-processing. So the first thing that is done is to transform columns by scaling the following. It's going to scale age, monthly income, loan amount, repayment defaults, and membership year, and then encode this other categorical features. And then after that, it does the classification and then passes the data to our training of our learning model. So once our model has been trained, we can now evaluate it, we can test it. So we pass the data set for testing, the 20% that we set aside for testing. So we will pass it here, and after passing the data, we can now evaluate it by printing out the various reports. So we have an accuracy of 0.5, and then on the classification reports, we have it shows us the precision, the recall, the F1 score, and the support. So that is the data that we have there. We can now plot our confusion matrix that is going to show us the relationship between our predicted and actual data sets. And then finally, we can plot our curve, our ROC curve, that will show us the relationship between the false positive and the true positive rates. So that is what we have here. So this is the confusion matrix that shows us the predicted versus the actual. The predicted versus the actual.